In this physics tutorial, you will learn 1. The meaning of multiplication of a vector by a scalar. 2. How to express the division of a vector by a scalar in terms of multiplication. 3. What are some examples involving the multiplication of a vector by a scalar in physics? 4. How to multiply a vector by a scalar in coordinates. Introduction. In geometry, precisely when discussing about similar figures, you have learned that two similar figures are identical in shape but their dimensions are different. For example, two squares are similar as they have the same features, they both have 4 equal sides, 4 right angles, 2 equal diagonals, etc. However, their respective sides' length are different. Look at the figure on screen. From the similarity rules, we can write for the squares previously shown. As the sides of the second square are twice the length of those in the first square, 6 cm equals 2 times by 3 cm. Do not confuse the magnitudes of the respective surface areas with the side's dimension. The area of the second square is 4 times the area of the first square, but here we simply wrote square 2 equals 2 times by square 1, not area of square 2 equals 2 times by area of square 1. It is clear that both figures have the same features except their dimensions. For instance, their lower base is horizontal, the lateral sides are vertical in both squares and so on. Hence, we can say, in similar figures, all the other features except the dimensions are the same. This affirmation will help you in understanding the multiplication of a vector by a scalar. Multiplying a vector by a positive scalar. The similarity rule discussed in the introduction section is applied in all the other fields of science as well. Vectors do not make any exception in this regard. Therefore, if we want to multiply a vector by a positive scalar, the result will be a new vector whose characteristics, direction, unit, the physical quantity they represent, etc., are all similar to the original vector except length. Thus, if we read in a certain passage that c, d, equals 3 times by a, b, we understand 3 things. 1. Vectors, a, b, and c, d, have the same direction, they are parallel or collinear. 2. They do not always represent the same type of physical quantity. It only occurs when the scalar has no unit. We will discuss this point in the solved example. However, in this case the scalar 3 has no unit. Thus, here both vectors are measured with the same unit. 3. The vector, c, d, is triple in length the vector, a, b. The figure on screen shows an illustration of this example. From the figure, you can see that both vectors have the same direction, as they are parallel. However, the length of the vector, c, d, is triple of the length of a, b, as c, d, is 9 units long and a, b, is 3 units long. Hence, we can write. We can generalize this rule by writing, if a vector, u, is parallel to another vector, v, and the length of u is n times greater than the length of v, then we get the equation shown on screen, where n is a number, scalar. Example 1. A ship can carry a maximum of 20 million N load when floating on pure water, on a lake. What is the extra load, in newtons, that the same ship can carry if it is floating on salty water? Take the densities of pure and salty water equal to 1000 kg per meter cubed and 1030 kg per meter cubed respectively. For simplicity, take the gravitational field strength, G is approximately equal to 10 nkg. The equation used to calculate the lifting force of water is, F equals, rho, times by G, times by V, where V is the volume of the ship immersed in water and ρ is the density of water. Solution 1. Since the ship is floating on water, its weight is balanced by the lifting force of water. Density and volume of water are both scalar quantities. Only gravity, gravitational field strength, and lifting force are vectors. Therefore, this is a typical example of multiplication of a vector by a scalar, where the result is a vector. First, let's calculate the volume of the ship. Thus, for the ship floating on pure water we have. Since there is the same ship in both cases, the volume is the same. Therefore, when it floats on salty water, we have. Therefore, the ship can hold 20,600,000 N, minus by 20 million N, which equals 600,000 N, more load than when it is floating on pure water. Division of a vector by a scalar is multiplication with the inverse. In the previous video, addition and subtraction of vectors, we have pointed out that in algebra there are only two basic operators, addition and multiplication. Subtraction and division are considered as subsidiaries of these two basic operators. Thus, subtraction is regarded as addition with the opposite, while division as multiplication with the inverse. Given this, it is obvious that if we have a vector, u, and we want to obtain a new vector, v, which has the same direction but is n times smaller, we can mathematically express this statement in two ways. For example, the Newton's second law states, the acceleration, a, an object acquires due to the action of a force, F, is proportional to the force and inversely proportional to the mass, m, of the object. Acceleration and force are both vectors while mass is a scalar. Mathematically, this law can be written in two ways. Therefore, either we divide the vector, f, with a scalar, m, to obtain another vector, a, or we multiply the vector, f, to the inverse of the scalar, m, to obtain the same vector, a. Example 2. An object is pulled horizontally due north by a 120 N force. As a result, it accelerates by 1.5 meters per second squared. What is the object's mass in kg? In what direction is the object accelerating? Solution 2. 1. Using Newton's second law as mentioned previously, we obtain the equation shown on screen. 2. Given that when multiplying a vector by a scalar, the result is a new vector, which has the same direction as the original vector, the direction of acceleration is due north as well. Multiplying a vector by a negative scalar. It is obvious that when we multiply a positive vector by a negative scalar, this results in a negative vector. This is because a plus times by a minus equals a minus. Therefore, when multiplying the vector, u, by a negative number n, the result will still be v equals n times by u, but the direction of v will be the opposite of u. For example, if n equals -2, the vector v is twice as long as the vector u, but these vectors have opposite direction. Look at the figure on screen. From the figure, it is easy to notice that when a vector is obtained by multiplying another vector by a negative scalar, the two vectors in question are antiparallel. The same is true for the division of a vector by a scalar as well. The two vectors will have again opposite direction. The only difference is that the second, output, vector will be smaller in length than the first, input, one. Example 3. An object moves linearly by 24 meters due west. Then it moves in the opposite direction by 1/3 the magnitude of the first displacement. What is the second displacement of the object in meters? Show the two vectors in a figure by making a suitable sketch. What is the final position of the object if we take 0 as the initial position? Solution 3. 1. This is a typical example of the division of a vector by a negative scalar where the final vector will have an opposite direction to the original one. Since the first displacement, delta times by x1, is due west, the second displacement, delta times by x2, will be due east. We can write the equations as shown on screen. 2. The situation is graphically represented through the figure on screen. 3. From the figure, it is obvious the object's final position, which represents the total displacement, delta x total, is calculated by adding the two displacements. Thus, we have the equation as shown on screen. Therefore, at the end of motion the object will be at 16 meters due east to the original position. How to multiply a vector by a scalar in coordinates. A vector is usually represented in coordinates as the equation on screen shows. When the vector is in two dimensions, its z-coordinate is not written, or it is simply written as 0. When the vector is written in this way, we assume the starting point, del, of the vector is at the origin, 0, 0, 0, and the given coordinates represent only the vector tip. For example, if we say an object is actually at 3 meters, minus 2 meters, 9 meters, we assume the object has moved 3 meters due positive in the x-axis, 2 meters due negative in the y-axis and 9 meters due positive in the z-axis after starting its motion from the origin. Look at the figure on screen. If taking the initial position of the object as 0, 0, 0, then the vector in the figure is written as shown on screen. Now, let's suppose the object moves at the same direction by triple the actual displacement. It is obvious we will obtain a new vector delta x2, which is collinear with delta x1, but it is 3 times longer. There is no need to plot the vector delta x2 in the graph, although it is shown here, as sometimes it is not possible to show everything in the graph, but we can simply multiply each coordinate by 3 instead. It is obvious that both vectors are collinear as they lie in the same direction. However, the second vector is triple as long as the first vector. Thus, we obtain the vector as shown on screen. Therefore, the rule says, to multiply or divide a vector by a scalar in coordinates, we simply multiply or divide each coordinate of the original vector with the given scalar. The result represents the coordinates of the new vector. Mathematically, we can write the equation as shown on screen. The same method can be also used for the multiplication of a vector by a negative scalar or for division of a vector by a positive or negative scalar. This method is much easier than solving the questions graphically. Summary. If we multiply a vector by a positive scalar, the result will be a new vector whose characteristics, direction, unit, the physical quantity they represent, etc., are all similar to the original vector except length. Thus, if we read in a certain text that c, d, equals 3 times by a, b, we understand 3 things. 1. Vectors a, b, and c, d, have the same direction, they are parallel or collinear. 2. Not always, they represent the same type of physical quantity. It only occurs when the scalar has no unit, is dimensionless. 3. The vector c, d, is triple in length the vector a, b. We can generalize this rule by writing, if a vector u is parallel to another vector v, and the length of u is n times greater than the length of v, then we get the equation as shown on screen. Where n is a number, scalar. If we have a vector u, and we want to obtain a new vector v, which has the same direction but is n times smaller, we can write the equation in two ways. When multiplying a vector u by a negative number n, the result will still be v equals n times by u, but the direction of v will be the opposite of u. For example, if n equals -2, we obtain the equation v equals -2 times by u. The vector v is twice as long as the vector u, but these vectors have opposite direction. The same is also true for the division of a vector by a scalar. The two vectors will have again opposite direction. The only difference is that the second, output, vector will be smaller in length than the first, input, one. To multiply or divide a vector by a scalar in coordinates, we simply multiply or divide each coordinate of the original vector with a given scalar. The result represents the coordinates of the new vector. Mathematically, we can write the equation as shown on screen. The same method can also be used for the multiplication of a vector by a negative scalar or for division of a vector by a positive or negative scalar. This method is much easier than solving the questions graphically.